This lesson's about multiplying radical expressions, and so I make the warm-up a little bit longer than normal because I want to introduce some concepts and some different methods of multiplying radical expressions to the students before they start the independent practice on their own. And so square root of 4 times square root of 4, when you multiply those two radical expressions, you multiply the inside of the radicand, which is 4. And so square root of 4 times square root of 4 is square root of 16. When you multiply those radicands, you get square root of 16, and then you get that's equal to 4 because it's a perfect square. Then commutative property says that if you look at this, it's basically multiplying on number 2. 2 times square root of 3 times 3 times square root of 6. They're all being multiplied. And commutative property of multiplication says that you can multiply in any order, you'll still get the same answer. 2, but if you want to, most of the time people will multiply the whole numbers, the 2 times 3, but you don't have to multiply in that order, it's just that those are going to combine and make 6, and then the radicands would be 3 times that 6 underneath would be 18. Now 6 square root of 18, is that simplified? No, you need to go ahead and simplify that. 2 times 9, well, square root of 9 is going to be 3, and so now you have 6 times 3 because whatever comes outside is multiplied, and then square root of 2, so it's 18 square root of 2 is the answer for number 2. Then I talk about polynomials and remind the students what distributive property is, or ask them what property is being represented in number 3, and its distributive property that 2's on the outside needs to be multiplied in. 2 times x is 2x. 2 times negative 3, remember, positive 2 times a negative 3 is negative 6. And the same thing's going to happen with radicals. You're still going to apply the distributive property. So negative 4 times square root of 5 would just stay negative 4 square root of 5. Then a negative times a negative is a positive 4 square root of 4. And those, now since it's being added, those do not simplify because remember you have to have like radicals, the same number underneath the radical, to be able to combine those. So that's actually your final answer. Then I talk about, well, when you multiply polynomials, I wanted to remind them what happens with polynomials when that happens. Remember, you distribute that x to both terms in the second parentheses. That would be x squared because you add the exponents when you multiply, plus 3x. And then you distribute the negative 2, multiplying it times both terms in the other parentheses. That's going to be negative 2x and then minus 6. And then you check to see if you can combine like terms, so it's x squared plus x. When you do it, take 3 minus 2 and then minus 6. And we'll apply the same thing to the radical expressions. 1 times 1 is 1. 1 distributed to square root of 6 is just going to be positive square root of 6 because that's a positive times a positive. Negative square root of 6 times 1 is negative square root of 6. And negative square root of 6 times positive square root of 6 is negative square root of 36. So these go to 0 in the middle. And then you have 1 minus 6 because the square root of 36 is 6. And so your answer is negative 5. You actually don't even have a radical left in your final answer. And those are called conjugates. Every time you multiply conjugates, which are just the same terms, opposite signs, I've mentioned it before I think in this class, but they go to 0, the middle terms go to 0, and you're just left with the first terms being multiplied and the last terms being multiplied for your final answer. And then number 7, I just wanted to show you an example of if you have the indexes are different, if it's not square root of 2, if it's cubed root times the square root where the index is indicated to be 2, then you cannot multiply those unless they have the same index.